Hello, I'm Patty Simpson with Simpson Ad. Let's look at the shape of our distributions. So I own a bar, and one weekend I asked the patrons about their salaries they made. And most of my patrons said they made $35,000 a year. But then in walked Ryan from Ryan's Toy Review on YouTube, and he made $22 million last year. So when I asked them about the average, or when I found the average of their salaries, if I looked at the mode or at the median salary, all my patrons made $35,000 a year. The average patron made $35,000 a year. But if I find the mean average, Ryan, making that large amount, $22 million, pulls my average to the right. It makes my average then be $2 million, $231,500, if we shared all that money evenly. So notice that that one number pulls that mean to the right. The same thing happened when we looked at the surgeries at St. Paul's Hospital. When we found the mode, it was 30,000. It was the one that showed up most often. The median was at 42,500. So our average cost was there, but then this one large surgery, $250,000 surgery, pulled our mean again to the right. It really skewed that average. And that's what we say. We say that one value skewed our mean, or pulled our mean to the right. It skewed that mean to the right. And we can see this when we create a frequency distribution of the data. We can see that the mean is being pulled to the right. So here are three different types of shapes of our distribution that happen when we have our data. So for instance, here's retirement ages. We have our ages and our frequencies of those who retired. And when I look at it, this distribution is very symmetric. So in other words, my data, if I draw a line right down the middle here and fold it, my data matches itself pretty well. When a distribution is symmetric, we know that there's no data value that's pulling my mean one way or the other. So my mean is about the same as my median is about the same as my mode. So I can look at a symmetric distribution and I can find about where my mean, my median, and mode are just by looking at it. I know that my modal bin is here because it has the most, it's the tallest, that frequency is the most. And since it's a symmetric shape, I know that my median will also be between 56 and 59, and my mean will also be between 56 and 59 of that data. So by just looking at the shape of my distribution, I can tell you about where my mode, median, and mean are. I can approximate those averages. In this case, though, I have salaries in the thousands, and the salaries are shown here on this distribution. Notice here that most people made between 20 and 30,000, but there were a few people that made more. These few people that made more are going to skew this data to the right, just like Ryan skewed our data to the right, and the large surgery, this patient number 8, skewed that data to the right. Here, these few people skew that data, pull that mean to the right. So this distribution is right-skewed. That tail, that data here to the right is pulling our mean there. And so in that distribution, I know my mean is going to be greater than my median. The mode is easy again to find in this distribution. The modal bin is always the highest bin. So I know my mode is in that $20,000 to $30,000 range, somewhere in there. The median I can find which bin it's in by using the frequencies. I know that there were 30 people here, 25 people there, 15 people here, 10 people there, and 5 people there, for a total of, well, that's 55, 65, 70, 85. So there's a total of 85 different values. Remember, to find the median, we can split that in half, and we know that 42 and a half, the 43rd piece of data, when they're all lined up in order, is going to be our median. Then 42 will be below it, and 42 data values will be above it. So I need to know which bin is my 43rd data value in. Well, 30 of them are in here. So the 43rd one is going to be in this bin. 30 salaries that I write down are in here. The 43rd one is going to be in here. So my median is somewhere between 30,000 and 40,000. So my mode is in here. My median is somewhere in this bin. And then from the shape, I know that my mean is going to be bigger than my median. So whatever my median is, my mean is going to be a little bit larger than that. It's being pulled that direction. So my mean, is somewhere right in there, being pulled to the right as well. So that's how we can use that shape to help us find our mean, median, and mode. Then, in this case, I'm looking at a dot plot where we've seen our books that are read, the number of books that were read. And in this case, most people read 6 books, but these few people that didn't read any or only read 1, that's going to pull my mean down to the left. Think about when you've got all great grades and then all of a sudden you forget to turn in a paper. It pulls your grades down to the left. So just that one value can skew your grade way down. And the same thing's happening here. These few values on the left are skewing that mean, pulling my mean to the left. So we say this distribution is left-skewed. And we can do the same thing to help us find the mean and the median and the mode, or to approximate that mean, median, and mode. We know the mode is here. That's always easy to find. The median we can find as well about where it is. Well, in this data, we can actually find it. In the histogram, we've lost our data, so we can't find exactly what that median is. But here I can actually find my median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I know it's the 9th one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there's 8 below it, 6, 7, 8, and 8 above it, 6, 7, 8. So 4 is my median there. Then my mean, I could add all those up and divide by the 17, or I can also know that it's going to be pulled to the left. So just to save us time, I'll approximate instead of actually finding it and say that my mean is about 3 because it's being pulled to the left. So you can use your shape of your distribution to help you to approximate that mean from the median and mode. So we can also picture the shape of our distribution if we know the mean, the median, and the mode. So if I know that my mean is greater than my median, then I know that my distribution is skewed to the right. If I know that my mean is less than my median, then I know that my distribution is skewed to the left. And if the mean, median, and mode are all about the same, then I know that my distribution is fairly symmetric. So those distributions just tell us a little bit about our averages. Math Made Simple is Simpson Math. Thanks for watching.